All right, hello and welcome. This is going to be our lecture video for March 25th and 26th, depending on which day you would normally have class with me. We're going to be doing just some practice with elimination. I've got these worksheets linked on my website if you want to print them off, or the problems aren't very long. They're pretty easy to just copy down if you want to do them on a separate piece of paper. Just going to do a couple worksheets. No new content, just practicing elimination with you guys. All right, if you've got this printed off, go ahead and put your name up there. I'm recording this on the 25th, so I'll put the 25th right there. Our goal is to practice elimination. All right. We can solve systems of equations by eliminating a what? By eliminating a variable. All right. Two terms will eliminate when their blank form a blank, when their coefficients form a zero pair. Let's have an example of this real quick. An example of a zero pair would be something like 8x and negative 8x. That's a zero pair because they cancel each other out. All right, if a variable doesn't eliminate on its own, you have to use multiplication. To create your own zero pair. All right, we'll see examples of that down below. All right, example 1. Do I see a zero pair? Well, it has to be on a matching variable. So the -3 and the 6, nope, that doesn't work. The 5 and the -3, nope, that doesn't work. So we're going to have to do that multiplication. So I see that, well, 6 is a multiple of -3. So maybe if I just multiply this top equation by 2, I can turn that -3 into a -6, and then it'll be the zero pair of this 6. So I'm going to copy this one. So I'm just going to say it times 1, meaning that everything's going to stay the same. So in that top equation, I multiply everything by 2. I get -6x plus 10y equals 48. And 6x minus 3y equals 15. All right, now that I've got that zero pair, I'm going to put a line underneath these. They're still nicely lined up with like terms. I'm going to put a plus somewhere out in front here to show that I'm going to add all of these like terms. The equal sign stays in the middle. The -6x and the 6x cancel out. And the 10y and the -3y, they combine to be a 7y. 48 plus 15, let's see, that's 63. All right, and now I'm going to finish solving for y here. Now that y is the only variable remaining in the problem, it can be isolated. So divide both sides by 7, we get y equals 9. This is only part of our answer. This here has to come and get plugged in somewhere. I'll plug it in right there for that y. It's 6x minus 3 times y, but y is being replaced by a 9, equals 15. So I copy down that second equation, but I replaced y, so now x is the only variable remaining in this equation, and I can solve for x. So 6x, -3 times 9 is a -27, equals 15. Add 27 to both sides. 6x equals 42. Divide by 6, divide by 6. X equals 7. And now I'm going to put that together into an ordered pair, 7, 9, with parentheses and a box around it because that is my final answer. All right, now you go ahead and try this one here. I'll put up my work. I'll pause the video for a second. All right, so there's my work for the you try number 1. I wonder if we found a zero pair the same way. I multiplied the top equation by a 4, Then I made a negative 40 to match this positive 40. Divide both sides by 16, we get x equals negative 5. Plug it back in, solve, we get y equals 1. And then I double check by taking both of these and plugging them into the top equation to make sure it works. And it does make it balance. All right, let's look at example number 2. Let's see, how can I make a zero pair? Well, again, I don't have a zero pair right off the bat, but I've got some multiples. I've got 6 as a multiple of 3. So I need to make this a zero pair. So if I multiply that bottom equation by a 2, then it'll be identical. So I need to multiply by a negative 2 so that this becomes a negative 6 to match that positive 6. And then I'll keep this top one the same, times 1. All right, so now I've got 6x plus 12y equals negative 12. And on the bottom, I've got negative 6x minus 10y, multiplying every single term by that negative 2, equals positive 6. Negative times negative is a positive. All right, now we got the zero pair nicely lined up, so I'm going to add these together. The 6x and the negative 6x cancel out. 12y and the negative 10y, those become a 2y. And negative 12 and 6, that becomes a negative 6. Divided by 2 divided by 2, y equals negative 3. Plug that back into either of these original equations. I'll plug it in right there. And you get 3x plus 5y, but y has been replaced by negative 3, equals negative 3. And we'll keep solving here. 3x minus 15 equals negative 3. Add 15 to both sides. 3x equals 12. Divide by 3, divide by 3. X equals 4. Now I can put that together into an ordered pair, always x comma y, so 4 comma negative 3. Parentheses, box around it, that's our final answer. Now, since we used the second equation to solve, let's use the first equation to double check. I'll just do this out loud. 6 times 4 is 24. 12 times negative 3 is negative 36. 24 minus 36 is negative 12, so negative 12 equals negative 12. It checks out. All right, you go ahead and try this one here. I'll pause the video, do it myself. All right, did you get the answer of negative 5 comma positive 1? I used the second equation to solve, so let's double check the first equation here. Negative 3 times negative 5, that's a positive 15. Plus 2 times 1 is a 2, so 15 plus 2 equals 17. 17 equals 17. It checks out. All right, a couple more on the back side. Let's see. One thought with example 3 here is that I could multiply to get a zero pair, but we haven't seen this before. It's also sometimes possible to divide. So the zero pair of a negative y would be a positive y. Well, I can turn a 2y into a positive y by just dividing by 2. And all of the other coefficients are even, so I'm not going to end up with fractions here if I divide everything by 2. And then keep this one the same. So the top is now going to become, let's try a little arrow, I'm dividing everything by 2. 2x plus y equals 4, and then the bottom is 16x minus y equals 14. And now these can be added together, and we'll be able to solve for x. So 18x is 18 divided by 18, and that x equals 1. Plug that in here. 16 times 1 minus y equals 14. 16 minus y equals 14. Minus 16 minus 16. Negative y equals negative 2. Divided by negative 1. We get y equals positive 2. So x comma y is 1 comma 2. Put a box around our final answer and double check the first one. 4 plus 4 equals 8. 8 equals 8. It checks out. All right, you can use a really similar, well actually, not just a really similar, these two are identical. something makes me think I might have fixed this on the worksheet I handed out in class, but this is the one that's linked to my website. So don't have to do it twice. We'll skip on down. The practice down here just wants you to rewrite each system so that one of the coefficients forms a zero pair, but you don't have to solve. All right, so we're just practicing making that zero pair. Let's look at this one. I can make a zero pair with the x's, but I have to multiply both of them. It's easier with the y's because 4 is a multiple of -2. So what I'm going to do is I'm just going to copy this one. 3x plus 4y equals 12. And I'm going to multiply this one by 2 so that I can get 4x minus 4y, there's my zero pair, equals 20. So I multiplied the bottom equation by 2. All right, I'm going to do the next 3. And I'm going to try and get a zero pair in the easiest way possible. So you try the next 3 on your own, and we'll see if we have matching answers. All right, here's my work for these. So for this one here, I multiplied the top by -2. That made a zero pair with the y's, 14y, -14y. For this one, I multiplied the top by -8. That made a zero pair with the x's, -8x and +8x. For this one here, I multiplied the top by 3. That made a zero pair with the y's, -30y and +30y. All right, just a couple more. Let's look at these bottom two together. So at the bottom, we see we've got a little bit longer sentence. So solve the system using elimination, multiply the top equation by blank. You can also solve this by multiplying the bottom equation by blank. So if I wanted to multiply the top equation, I could make the x's match by multiplying the top equation by -2. And that way I can get 2x and a -2x to be my zero pair. I could also get a zero pair with the y's. The opposite of a 3 is a -3. This is a -y, so you can multiply the bottom equation by a 3. Pick one of those and write it over here. And for this one here, we can multiply the top by what? Well, we can make the x's match by multiplying by a -3. That way we get a -15x to match our +15x. Or multiply the bottom by 4, so we get an 8y to match our -8y. So this shows you there's no one right way to do it. You could do these problems in a lot of different ways and still get the right answer. Okay, the next worksheet I want to focus on is the standardized test prep sheet. Again, linked on my website, or you can just watch along here. It's going to be a little bit more impactful for you if you try these on your own first. But here we go. Use the system seen here for exercises 1 and 2. And we just can read these. What's the x value? What's the y value? Looks like we need to solve this. So do we see a way to easily make a zero pair? I do with the y's here. I can make these match because 10 is a multiple of 5. I could also do it with the x's. And neither of these can be simplified, so we're going to have to multiply. So I'm going to multiply the bottom equation by 2 and keep the top equation the same. So now I've got 4x minus 10y equals -3, and 24x plus 10y equals 24. All right, add these together. The -10y and the 10y cancel out. I've got 28x equals 21. Divide both sides by 28, you might feel like you've done the problem wrong because x equals 21 over 28. Well, this is a fraction. We never get fractions. But all of the answers are fractions, so we could still be doing the problem right. Let's divide the top and the bottom by 7 here, and we get x equals 3 over 4. And that is one of our answer choices. So we're feeling good about that because we solved it. And then we found that the answer was in the answer choices. All right, to find the y value, we got to go plug that back in. So I think the easiest place to plug it back in would be right here. 3 over 4, because 4 times 3/4 is just a 3, so that'll be nice. Here, I'll show my work up here. So 4 times 3/4 minus 10y equals negative 3. So the 4's cancel out, and this is just 3 minus 10y equals negative 3. Can subtract 3 from both sides. I get negative 10y equals negative 6. Divide by negative 10. Get y equals, and negative 6 divided by negative 10, the negatives cancel out, and this becomes a 3/5. 3 over 5. All right. Which of the following systems has the solution 4 comma negative 1? This is an interesting way of asking this, because now I've got the x and the y, and I need to figure out which system does this make both equations true. And if I find that either equation is false, I can cross it out right away. And we'll just go in order. There's no, we could maybe use some strategy to pick one to start with, but I'll just start with A. So 3 times 4 is 12, minus 2 times negative 1, that's going to become a plus 2. So 12 plus 2 equals 14. That one checks out. 2 times 4 becomes an 8. 2 times a negative 1 is a negative 2. 8 minus 2 is 6, so these both check out, and A is our answer. I actually didn't know that A was going to be our answer. I just picked it at random, but we got lucky right off the bat. Let's check and see that B is not our answer. So 3 times 4 is 12, minus a negative 1 is the same as plus 1, so 12 plus 1 is 13. See, that doesn't work. And it's not even worth checking the second one, because once the first one doesn't work, you know the whole thing won't work. And actually all of these wouldn't have worked. But we got lucky. That was an example of a problem where you had to look at the answer choices first. There's no way to solve it without looking at the answer choices. All right, at a bookstore, used hardcover books sell for $8 each, and used softcover books sell for $2 each. If you purchased 36 used books and spent $144, how many softcover books did you buy? So we haven't seen a word problem like this yet, but I'm going to show you how to set it up. So I'm going to use H for the number of hardcover and S for the number of softcover. And I'm going to write equations here. So if I bought 36 books, then the number of hardcovers plus the number of softcovers equals 36. But if I spent $144, then $8 for each hardcover, I'm getting that from right there, plus $2 for each softcover must equal 144. So now I've got my system. I could take this and multiply it by negative 2 to get my 0 pair, and I would get negative 2h minus 2s equals negative 72. Add these together, I would get 6h equals 144 minus 72 is 72. Divide by 6, we get the number of hardcovers equals 12, but that's not our answer. It says how many softcover books do we buy? So plug that back in. We'll just plug it into that very first equation right there. 12 plus s equals 36, minus 12 from both sides. S equals 24. So there was kind of a trick answer in here. If you stopped too soon, you would have picked G and gotten it wrong. You have to plug it back in to find S, the number of softcovers. So read the questions very carefully and always finish the whole problem. All right, last one. I will write up my work for this one and then unpause the video so you can see it. So go ahead and try that one. All right, and here's my answer to the extended response. So to set up the equation, I said y would be the cost and x would be the number of minutes. We multiplied the cost per minute by number of minutes and then add on that flat fee. I then solved the system of equations just for x to, oh, actually I didn't finish solving d yet, so I'll do that with you guys. So I solved for x to figure out that right at 230 minutes, they cost the same. So my answer to B is less than 230 minutes. Plan A is cheaper because it has the lower flat fee. and after 230 minutes, plan B is cheaper. Then in read D all the way, how much does it cost when the plans are equal? So for that, I need to plug that 230 back into either of my equations and solve. I'll plug it into the top equation, y equals 0.35 times 230 plus 30, y equals 80.5 plus 30, y equals $110.50. So that's our proper answer to D there, $110.50. And we can check that by plugging in 230 into the other equation. I'm doing that now. 1150 plus 99 equals 110.5. All right, so we'll call that good for today's lesson, and have a good rest of your day.